quick introduction. Shout out to our bronze sponsor, SysDic, for helping sponsor this conference. Absolutely love it. 10 out of 10 conference, would go again. And now, a quick intro to Lee's talk on, hello, whose service account keys are these?
Hello, everyone. Great to be here. Thank you for bearing with the technical issues as well. So let's get moving. My name is Livsey. I'm a security consultant at ReverseSec. So we work on offensive security for clients to help them out to look at things they produced in their estates to see is there better security postures and things they can do, let's say vulnerabilities, things like that. Big range of experience in different areas, but the ones of most relevance is that I've started to like focusing on GCP assessments. There's also previous experience of relevance within AWS workloads, and I've seen that's a transition that a lot of people are making. So I've been in the Cloud Security Forum Slack, and from chatting to clients, that people will be of previous experience working with primarily AWS, well then there might be a merge to a multi-cloud of let's move to GCP, a few attractions being maybe Gemini, and one where Google themselves and the cost factor. If Google's trying to motivate people to move across and use their compute, then that's something that's moving across. But then developers and security professionals within organizations have to work with them. So I'll make note of a few comments I see from my journey when we get there. And yes, this is going to be another talk about long-lived credentials within environments, but specifically on GCP, because it doesn't get talked about enough as a cloud platform. So we're going to have a bit of an overview and find out, so you go away from here with a knowledge of what do long-lived credentials look like in GCP estates, how can you identify them, and methods to reduce them or eliminate them entirely from your environment. Along the way, we'll talk about a case study of a finding I found within a GCP managed service. And guess what? There was a long-lived key there that allowed some access into the estate. So we'll start with some background. I think this slide was a bit of an overview to think of, remember, long-lived keys are an issue. There's been a lot of talks already that have covered that within the conference. So I think that's an accepted fact. Two that kind of spring to mind and come up within sort of engagements. When credentials are pushed to GitHub repositories, attackers will go and look and find them. And there's other ones where an initial access may start on an on-prem. The client does their enumeration, or the attacker does their enumeration, and identifies long-lived keys to allow them to pivot from the on-prem instances into the cloud estate. So the dangers of long-lived keys are not just on AWS, which we've heard a lot, and Azure. They happen in GCP as well. We're going to take a little bit of a journey for one slide around what IAM looks like in GCP, because from my transition from AWS to GCP, there were a couple of things that were maybe surprising. I'd spent around 2 years where the whole focus had been get rid of user accounts from the environment within AWS because there's long-lived keys there. But in contrast on GCP, from what I've seen, there's much better default patterns there, and it's typically done well. So client organizations will typically work from the Google workspace, use as their directory if they're single just with Google. But there's also options if you're moving towards multi-cloud with Azure, with the ability to have a connection between your entry environment as well. So I think when you've got those directory-based identity providers with MFA configured on the account, it's kind of typically done well. Service accounts, so those are the accounts that are able to do machine-to-machine communication and authentication within GCP. Really, there's two types of interest. So one, the Google-managed service accounts or service agents. CatTraxler has done some very interesting work in previous forecast talks and a recent white paper about service agents and digging into them. This talk isn't going to investigate those types of service accounts. We're going to be concentrating more on the user-managed service accounts. So those service accounts, the keys for those service accounts that you create within your projects to allow access to resources from outside of your account. There are a range of things that are not done as well, typically if they're long-lived. So just as well with more background, what does a GCP service account key look like? Well, it's a private key. So these were kind of then that familiar thing, back to where like being so comfortable. Oh, okay, I know what these look like. Those strings there within the begin private key. There's something to be looking out for. The interesting thing of when you go and try and create them, and there's one step that we'll get to later before you get here, if you have a service account key and you're trying to create a new key for that service account, there's a couple of screenshots here that show the process, but there's no option to manually configure the lifetime of that key. It's set to, as it was mentioned in the first talk this morning, the end of time. Ultimately, that's a decision that Google have made with their setup for a few reasons, what we'll get towards the end of the talk. But it seemed a little bit strange for me. And it crops up a lot in client engagements that I've been working on. So I think it's time we call this out. The community needs to know and be aware of it for people who are starting to move and have workloads within GCP. One last point before we get on to the case study was there's a number of partner-provided services, managed services within Google Cloud. So not all, my typical approach on an assessment with a new service, client comes in and, oh, we want to look at this. And the typical approach is go and read the documentation, find a test environment that we've got access to and like spin up a version of it, investigate, get hands-on experience with it. It wasn't possible to do it within the service that we're going to talk about. And some of them need quota. You need to reach out to your Google service partner or go to a partner organization who has quota to be able to implement them. So there comes a point there, if people aren't looking, then there's potential the security posture may not be as good as you'd want for a managed service from a cloud provider. So we get to the stage of contact center as a service. A client comes to us with a request. They wanted to know about the security posture of their new service. Okay, they'd moved their contact center into the cloud. One thing they were trying to get was more ETL analysis and data-driven benefits from there. They were interested in could they make it any better. So I spent my typical approach. Found out that contact center workers have it a little bit tough. So highlighted a few things there. The special task one seemed very interesting as well. Ultimately, I found there wasn't much to go on from the console of Google's console, and CLI support wasn't great either for enumeration. So all I was left with really was the web application, the portal that the client had given me access to. So I was like, oh, well, let's start looking through what we can do there. As you can see from the screenshot, there wasn't really a lot configured for us to do. But yeah, if we think about how would you not want your web app to maybe talk to back to your Google account, it's not a stretch to think, well, developers are used to know about service accounts and they use service account keys a lot. Maybe they might think, oh, let's use a service account key for our web application to talk back to the GCP estate. And in fact, that's what they did. So I saw this kind of response and request. The highlighted bits got me quite excited. And then playing around with a little bit of JQ and Regex magic, we get into the stage where the full private key is there. So we redacted out the actual content. But ultimately, we're in a position where we could authenticate to the client's GCP estate. So this is going to be an impactful one because it was also assigned a storage admin role. So the partner, so I'm kind of thinking my way through, the default expiry as well. So you got to the stage of, it's a user managed key where they had not configured the expiry for it. This was a mistake that the development team close to Google made. They manage and facilitate for clients a Google managed service. And they still made a mistake of using secret service account keys in a places where they probably shouldn't. And the point, well, one key takeaway here is that if we think about this, oh, that's maybe not a risk, or maybe these wouldn't be used, well, there's a clear example here of a case where they were. Thinking about the root cause, so from discussing with the client, this service used to be called Contact Center Artificial Intelligence Platform. I think what their main attractions was the artificial intelligence element of the service. The account key that we saw there was for a second project, which was kind of entitled ETL. So there was some certainly ETL jobs going on there, that data analytics to add value add on top. And what may well have happened, if you think about the infrastructure from the web application, that was in the partners project, but they were trying to push things to the client's project. I think it's simply they made a mistake in how that communication is going, that they know about service account keys, but not thought of the best way to securely implement that cross-project communication. The other thing that springs to mind is a parallel to Christoph's research related to vendors who are asking for AWS IAM users to be able to work on a cross-account. So this is an example that those risks there within AWS, there are also parallels within GCP. So now we'll spend some time thinking about some solutions and kind of on the CSP side and also on the kind of organizations and what they can do. The solution really with this use case is to think about federated identity workload where you can use it. I spent some time since this thinking about what was going wrong. The first thing is if you're sharing private keys within the responses of the web application, then any user of that web application is going to be able to see it and then start looking to use it and get a foothold in your environment. You already have a session channel from the authenticated web context, so the data you're trying to push into the client's environment should first go back to your estate. But there's still going to need to be a service account somewhere in the back end. So if you can get to the stage where the communication is within your own, as the partner within their project, then you could use the service accounts to push that cross-account without needing a direct key for the long-lived credential material. But there's also examples where you're external to the estate and you may be difficult to use workload identity. And the diagram here shows kind of a flow diagram of when you may need a service account key. And the importance really is to try and minimize that as much as possible to kind of reduce and move that boundary further and further away from the need for keys. Because at the moment, that seems to be an option that a lot of people are trying to go down, certainly within GCP. I think one point to move on with looking at the GCP documentation is interesting when I reviewed this. The expiry itself is not an accident. They do it intentionally because they're moving their main concern is that if these keys were to expire on production workloads, you may then get denied the ability to use that service, and it may impact, say, usability. But I think that's too much of a shift towards usability rather than security, and we need to make that balance. If you think as well about the service agent keys, they expire on a much shorter lifetime. So they're around a year, certainly nowhere near as long as the user-managed keys. And that's a distinction that I think is worth thinking about. Maybe as a community we should push towards Google looking to modify their approach to this. But this is not the thing in alone. There's also organizational constraints which can, one here that's enabled by default on newly created organizations is to enforce that it's not possible to create service account keys. So Google are trying to assist and push developers in the direction of secure by default. But at the moment, we're not in a place for this to be an effective guardrail. How many people are familiar with this organizational constraint who've used Google workloads and disabled it? A quick show of hands. Yeah, so there's people in the room who've done that. So we're not in a position yet where we can rely on that. One that we maybe can think about is the service account key expiry. You can set a value for the number of hours that you want new keys within your organization and projects to be valid for. That is something that you could leverage. You've got to be in a position, though, where you've got a good mechanism for managing key expiry. And this is then these screenshots are showing a little bit more as well with there's warnings within the console of trying to motivate people to do secure practices. But at the moment, we're not in a position where just disabling key creation is a viable guardrail. Finally then, a few slides. How would you identify such long-lived keys in your environment? Well, one way is with a simple bash script with a gcloud CLI. You can enumerate the service accounts within your project, list the keys, and then grep for the values. So you could go after 999 or 998. You do the for loop, you can imagine it. Something maybe more relevant, you could do 2027, 09. So you get into a stage of where if you want to restrict it down to in a year, sort of 18 months. That's something you're going to have to do, custom manage at the moment from the developer side. Or just look in the console. You could see them all listed there, project by project. Disclosure processing, it's worth calling this out. We reported the web application finding of seeing that service account key disclosed. Google were responsive. It felt quite efficient and well. There was no major pushback. And they triaged it really quickly, and it was fixed by August. So that felt like a nice process. It's worth calling that out in terms of where previous researchers have encountered difficulties with the cloud service providers. Finally, some key takeaways. I think what this talk has aimed to do is to raise awareness that long-lived credentials are an issue in GCP as well. For developers to be able to identify where they are within their estates, and to give some motivation for developers to move their workloads where possible to use federated identities. So for vendors, can you start supporting federated identification? Users in your organization, can you, as developers, push for vendors to provide that instead of the long-lived account keys? Thank you for listening. Happy to take some questions.
Thanks, Lee. There's one question there in the back.
Right in the back.
Should have been more specific.
Run.
My bad.
Hi. It's worth mentioning that other than generating this key from the GCP console, you can also use the method where you upload key. Mm-hmm. And in it, you can specify exactly how long do you want the expiration date to be. So actually, there is an option, but it's also a shame that GCP doesn't give you a nice tooling to do that. It is not possible with a simple gcloud command, but it is possible to set a custom expiration for everything.
Yeah, I mean, you're still not getting away from the long-lived keys. It's just you're managed them. Another option is certificate-based. So like as mentioned earlier, there was IAM roles anywhere. There's a way to do certificate-based access with a private CA as well. So that's maybe another option that people could think about. Yeah, valid.
There's one more.
Hello, thank you. Is there any way to have these keys not touch disks for storage?
So I think what you'd hope is they'll be on disk at some point. If you think of use, I think in my use cases that I'm in my head, say you've got devices that want to be able to go and talk into. There'll be some need to be on disk somewhere. I think in the management is how you do that. So like credential, key vaults, things like pulling back things back. I think it also depends on threat models of where do you think you're going to be compromised? How would access go in? But I think there's been a long history of these keys getting disclosed somehow, or people getting access and getting there. So yeah, that's fair. Nothing springs to mind kind of specifically to say we could avoid having this on disk and rely on memory, but there's going to be a lot of examples where that's not even possible because of, say, IoT devices and specific things of hardware restraints as well. So, okay.
Any more questions? No? All right then. Well, thanks, Lee. And yeah, round of applause.
Thank you.